So we've got two theorems that we're going to be talking about today. The first one is this radius tangent theorem, all right? So this is one of the two theorems. So this is in the main section, all right? Go ahead and click the next tab down so you guys can go ahead and take notes. So if we have a radius that intersects a tangent, our theorem says if a radius intersects a tangent, then they are perpendicular. Now, with them being perpendicular, it means that they form right angles. If they form right angles, then we have a right triangle. So you have two different types of triangles. You're going to either be using Pythagorean theorem, or you can use special right triangles. So all that review of 30, 60, 90, and 45, 45, 90 can come into play right here. So you're doing one of those two different things, special right triangles or Pythagorean theorem. So we have a radius. So for each of these, I'm going to go ahead and highlight the radius. The radius is from the center to the outside of the circle. From the center to the outside of the circle, we can put the radius in a couple different places, and they're on different angles and different lines. So those are my radii. So if a radius intersects a tangent, my tangent line is the line that is outside of the circle. So we have our tangent in different spots also. And then that other line is going to be our secant. However, our theorem tells us that they're perpendicular. So since something's perpendicular, it means that they form a right angle. So where these two lines intersect, the radius and the tangent, we have right angles, which means that I have right triangles. If you don't know your triples, you're going to be using Pythagorean theorem. Some of these don't have triples, so you have to use Pythagorean theorem. So for number 1, we're finding the missing side. The missing side that we have is across from the right angle. So what we're going to be doing for number 1 is solving for letter C in Pythagorean theorem. So we're going to be doing 7 squared plus 24 squared equals C squared. So you can very quickly, 7 squared plus 24 squared, enter. Square root, enter. You should get a whole number, and the answer is 25. For number 2, you're not given, or you're not looking for your hypotenuse. In this problem, you're either looking for A or B. We're looking for the radius. I'll call it A. So I'm going to do A squared plus 24 squared equals 26 squared. There's also 5, 12, 13 triple. If you don't know how to do triples, you're going to be quickly solving, all right? You're going to be quickly solving, and you're going to get that your answer is the number 10. All right, the square root of 100 is 10. Number 3 and number 4 are not triples, all right? The reason why number 3 is not a triple is because the 8 is on the hypotenuse. It's not a leg. So 6 and 8 have to be legs in order to be a 6, 8, 10 triple. For this problem, I'll just call this B. We're looking for the tangent line. So I'm going to do 6 squared plus B squared equals 8 squared. All right, so we've got our calculator. 6 squared, and we get 36. Plus B squared equals 64. I'm going to subtract 36 from both sides. So we have B squared equals 28. When I square root each side, I can break apart the square root of 28 into 4 and 7. The reason why I'm splitting it up into 4 and 7 is so that I could take the square root of 4 because it's a perfect square. So we get 2 square root 7 as our final answer. And then number 4, again, Pythagorean theorem. In this case, we're looking for C. We're looking for that hypotenuse. So we're going to do 4 squared plus 6 squared equals C squared. So in our calculators, we have 4 squared plus 6 squared, enter. And you should get 52. So we have 52 equals C squared. From there, we're going to go ahead and square root each side. And I'm going to have to break apart the square root of 52. I want to use perfect squares, so I'm going to use 4 and 13. I'm using 4 and 13 because 4 is a perfect square and 13 cannot be broken apart any further. The square root of 4 is the number 2, so we have 2 square root 13 for this problem. So take a look at 1, 2, 3, and 4. These are all the different kinds of pictures that we're going to be having today, and so on and so forth. 5 through 10, they're all the same pictures. We've gotten Pythagorean theorem. We've got triples. All right, we've broken apart roots. The last part that we have to do for using this theorem is to use our special right triangles. So for number 5, it says find the length of the tangent. So here's my tangent. Oh, I think I was doing blue before. So here's my tangent. I'm going to highlight that. The radius is from the center to the outside. That's the number 1. It's not asking for the radius. It's asking for the secant. All right, which will always be the hypotenuse. Now the radius and the tangent form a right angle. So I'm going to put a right angle in that corner. You have to know that that forms a right angle right there. Because one angle is 45 and another angle is 90, this is automatically a 45, 45, 90. So I'm going to go ahead and draw out my chart. 45, 45, 90. So we have x, x, x square root 2. We're going to put our 45, or the 1, right across from the 45-degree angle. So I'm going to put equals 1. So anywhere that I see an x, we're going to put the number 1. So we have 1, and then we have 1 square root 2. So the tangent line, that's across from the 45. Secant line, it's across from 90. So we have 1, and then we have 1 square root 2. You don't need the 1 in front of the root 2. For number 6, we've only got one angle, and that's 60. We're asked to find the length of the tangent, which is EI. And then it says find the length of the secant, which is segment PE. And the radius is the number 1. You all have to know that the right angle is at the corner of angle I. So since it's at the corner of angle I, one angle is 90, one angle is 60, the other angle automatically is 30. So I'm going to set up my 30, 60, 90 chart. We have x, x root 3, 2x. 1 is across from the 30 that you have to come up with on your own. That number is 30. One angle is 60, one angle is 90, the other angle has to be 30. So we're going to put equals 1, which means that anywhere that we see an x, we're going to put the number 1. So we have 1 square root 3, and then we have 2 times 1. Every single time, you're looking for your tangent, and we're looking for our secant. So we've got 60 degrees, that's across from the tangent line, 1 root 3. You don't need the 1 in front of the root 3. And then we have our secant line, which is just the number 2. All right. Number 7. So we're going to draw our 30, 60, 90 chart. When angle is 30, you have to come up with that 90 degrees. That's what our theorem told us. We're going to be looking for the tangent, and we're going to be looking for the secant. So we have x, x root 3, and then we have 2x. For this problem, the 1 is right across from your 60-degree angle. This one's a challenging one. So we're going to put equals 1 in the 60 column. All right, so we're going to divide each side by square root 3, and it doesn't divide. So typically, we just divide by 3 and put the root there. So I'm going to put 1 divided by 3, and then we put the root right next to it. So this is the actual number that we're going to be plugging in right here and right here. So for this problem, 30 is across from the tangent, 90 is still across from the secant line. So we have 1 over 3 square root 3, or you can write root 3 over 3. And then we have 2 times 1/3, which if you type that into your calculator, it's going to be 2 over 3. And then we put the root 3 right next to it. You can write it like this, or you could put 2 root 3 over 3, either one. you're not going to have weird numbers like the number 1 on your practice set or on the reviews or on the test. All right, it's just right here in the notes. All right, number 8. We're going to do our 45, 45, 90 chart because the radius and the tangent form a right angle. So we have our 45, 45, 90 chart. So we have x, x, x square root 2. Go ahead and solve this one. So for number 8, we should have just plugged in the 5 and then plugged in the 5 next to the root 2 to get 5 root 2. So the tangent line is 5 and the secant line is 5 root 2. Okay. 2 more using this theorem. 9 and 10. They're both 30, 60, 90 triangles. Go ahead and try these ones on your own. So this concludes the first part, the very first theorem of today's lesson. We have one more theorem to go to, which is concentric circles. So all a concentric circle is, it's a circle with the same center but a different radius, okay? So it's always going to be a circle inside of a circle. What you're going to be looking for is the chord, and you're going to have to connect the 2 radii to the chord in order to find the missing numbers, all right? So for number 11, we're going to draw 2 lines to connect the center to the chord. So I'm going to draw a straight line out, and that forms a right angle, and then I have one other line that we're going to form. Now, this smaller line right here is the radius of the smaller circle, therefore it gets the smaller number. The other line that we have, which is right here, that's the radius of the bigger circle, therefore that's going to get the bigger number. Every single time, what you're going to be doing is finding this whole thing right there. So again, we're going to put the 5 here, and I'm going to put the 13 right here. Every single time, you're looking for the chord. So what we're going to be doing is using Pythagorean theorem to figure out this measure right here. So I'm going to do 5 squared plus b squared equals 13 squared. If you know your triples, this should be quick. If you don't know your triples, then you're solving Pythagorean theorem, and you're going to get the number 12. However, 12 is not my final answer. We're going to have to double the 12 to find the length of a chord, just like we were doing yesterday. So my final answer is 12. 12 right here. My final answer is 24. Number 12 is pretty much the same thing. We're going to do another example. So again, we're going to draw 2 lines. We're going to connect these lines to form a triangle because we could use Pythagorean theorem to find the different measures. So this 18 is the smaller number, so I'm going to put it for the smaller radius. So I'm going to put this 18 right here. The other radius that we have is larger, and that's where we're going to put the 30. So once you find your answer, 24, you're going to have to double it to get the 40.